Here we are in lesson 5, our persistent game controller. Let's go over some scripts. We still have our pickup and our broadcast script. The player, this box controller has been upgraded, I would say. Changes are in the script. We still have our spawn point limit Y, our push controller, checkpoint, still using that, our static game board. We have one pushable cube and our persistent game controller. Persistent game controller has a lot of changes, including adding scenes to load via reorderable list. Can we undo those actions? We can also open the build scenes to add new build scenes while still maintaining connection to our game object. So this lesson will be heavy in editor scripting. We'll build I'll show you how all of this is built. We are not writing any scripts in this course. So there's some disabled properties. There's our game information, actual points, score, time we've been playing, other elements. Our max pickups are now dynamically counted and added to the amounts. This is just the default level that was set from the base game controller. And here's our scene index. So our scene names are no longer in a static menu. That was from our game controller. Let's check it out. Doesn't matter which scene I load. So here is our original game controller, and this is how we add a new scene name, of course. Now in the persisting game controller, we've improved quite a bit. So we just select the scene from whatever is available in the build scene. Cool. Let's start with the persisting game controller. I will hit the ground running in this episode, or because yeah, like I said, lots of editor scripting. So we inherit from our game controller here. We declare a static field for our instance. This is like say a singleton, but the instance is only going to be used inside of this class. So now we have our level names. We have a serialized field, which you should be used to by now, and we have a new what is this, a property? Yes, a new property here that's not defined in Unity. It's ours. It's defined in our assembly, and we'll see how that's done. We have our game information and our game state. In our wake, we check if the instance exists. If it does, we're out of here. We're checking to see if it does exist. If the instance is not null and the instance does not equal what's passed in, which is this currently loaded object, we'll destroy it because we already have a persistent game controller that we're using. So if all that passes, then we call Unity's DontDestroyOnLoad. That way when a new scene is loaded, we won't lose the information contained in this particular script. We set the instance to this. At this point, instance will always be null, and this will only ever be done once. The scene names from our base class, we set it to the new level names. Let me show you why this was done. It's a protected class, and we can't, in theory, let's say this lesson 4 namespace was not in our assembly. We won't be able to add another property attribute to this field. We need the property attribute to draw the scene picker. So this is how I've come up with a way to show you how to solve that problem. If you need access or to changing the property attributes and you don't have access to the class, you can create a new property and then assign it at the right time to mimic the old behavior. So our scene names are what's going to be used to change scenes and everything. The level names is just a container to carry our new behavior through. I hope that makes a little bit of sense. Then we start a coroutine, which is our game loop. Been through this. Override on pickups collected. So in our base class, we do something when all the pickups are collected. Here we want to change the behavior just a tad. So we want to add our points, our score, and we want to change the game state when our pickups are collected. In the game loop, changing our game state to game over will call this function here. So we'll go through that when we get there, but that's what we do in the new when we call on pickups collected in our base class. Let's take a look at that since we're not invoking it also. So it's the old behavior. Set the pickup counter to 0, which was unnecessary because it was destroyed and would always be initialized to 0. Nevertheless, then we call wrap scene index, which takes the current level or scene index from the array and adds 1 to it or brings it back to 0. Then we load the level. So the new behavior doesn't actually load the level. It sets the game over state to game over, and the state machine will take care of what's done next. Okay, so on startup, we just switch the state machine to loading in this class. When it's loading, it gets the game state playing. It's set game state to playing, which is there. We'll go over that. If it's playing, it just increases the time. And again, if it's game over, it heads on down, calls this function, and gives it an action to perform. And the action is our base game. So eventually we do call our base to load a new level, but in the meantime we want to do other things. So we override and we set it to game state over, and when game state is set to game over, it does some things before it calls our base. Okay, it disables. Here's the active input controller that we discussed at the ending of lesson 4. We set it ability active or being able to be used to false. We get the current box controller, the current player. We use our tag utilities for that, and then we just pull that component off our tag player. We set its direction to 0, and we disable the box controller, and then we invoke the function that was passed in. And the function, of course, that was passed in was we've picked up everything and load the new level. Okay, and again, from the scene names, it picks the next index. Now the difference here from before, when it loads the new level, our game state will still be maintained, the state of everything in this class. So it will still have the level index that from previous. It won't be reset. All these values would still be the same. So we would maintain our state here, go back into our loading state, and set to playing. In playing, we reset the time, we find the pickups, all of them that are on the screen, and we set our max pickups. I think this is pulled from the base class. Yeah. Respawn our player, and we enable control again. We set the game state to playing, and we resume. Alright, let's go back to the top and get into some of these fields we created. So the game info, it's just information. Quick thing. Structure, serializable, so it can be serialized as turned into data that we can store and pass from assembly to assembly or disk to all kind of stuff. No, look into it. Anyway, we have the three fields: points, time, and score, and that's all this structure contains. I'm sorry, I don't know if there's any. I don't think we needed that. Alright, cool. Don't want to pull in namespaces we don't need. Okay, now we can go into the game state. Send enumeration. I don't know if it needs to be serializable. I think I saw that on some of the Microsoft's C#, the base classes, and I think some of them had on their enumeration serializable field. I don't know if this is actually necessary, but at this stage I don't want to take it off, and I don't see what harm it causes. So the first state is idle, second startup, loading, playing, then the game is over. Now these are set up in a form. It takes the next one and it doubles it. That way, adding them, they're like flags. They'll never be the same two if you add them. And it provides a way for me to get into, let's say, between starting and loading, you may want to add another game state later. This method will provide that assurance. You know, if you add a few states in between here and there, you won't affect the current states. Yes, that's a hint of some good stuff that's going to come later. Alright, and from our game state enumeration, that's where we set all of these things up, we can see what changes we've made to our active box controller. Now through inheritance, we have to write a whopping amount of code here that I shudder to even start explaining, but I'll give it a shot. We declare publicly accessible is grounded, our own, other than the character controllers, that we don't need to keep passing in the game controller. The character controller. It's already embedded all here. And we changed the way the character can be moved and receive jump input. Okay, and that's it. So let's see what changes were made in the input manager. So now the input manager, we added a accessible value for enabling and disabling the input manager. And if it is enabled or disabled, it just returns, I guess, the best move direction to return on for a vector 0, that you're not moving. Or if it is enabled, it returns the input manager from the previous lessons here in 3, it does its calculations, and it does the same for the jump. Again, using what you've written before saves you. Yeah, I realized that, yeah, oh man, it would be cool to enable and disable this thing, but I didn't need it in lesson 1. It you know, as just building this thing, it's not something that I needed to continue. But when I got to the point where levels were changing, then the user can press a button and change things while levels are changing, and that can cause corruption of data. Then I needed this ability, and it was as easy as just creating some new functions with new functionality, that using the old functionality when necessary. Code reuse. Major. So now let's see the changes that were made in our active input. We saw those. Saw that. Now we can get into the property attribute. So we declare our own property attribute, which we use here. We can get into it. We declare the scene name, whether we want to show it or not. We'll see exactly what this does when we get into the drawer, which is the editor script. And we declare another boolean, whether to show an add scene button or not. We'll also see that. Read only, we set them in the constructor. Give them some default values. The default values, that's why you can do this. So given that the default value for use scene names is true, I'll get the same result. Okay, let me undo that. Now onto our scene picker drawer in the editor. First, we'll start here. Now the scene picker drawer inherits property drawer. It's a Unity editor namespace. And we declare an attribute, custom property drawer. We've seen before the custom editor drawer. Custom editor. We'll go over the persistent editors in a moment. But this is a custom property drawer. Tell it what type of property it's going to be drawing, and I believe this is the same as for children. Yeah, so any inheriting classes would draw the same. A couple of constants for sizing, and this is a label that's going to be drawn in the inspector, like text for us to see. We declare a style for our button that we're going to be showing, and we draw our custom scene picker. Line 1 gets all the build scenes from the editor build scene static class. So now that we have them, we can select each of them and stuff them into a new GUI content. This is also a label that will be drawn for each in that reorderable list. The select picks each one, and you can perform, it says here, an action on each element in the array. And this is accessible through system link namespace. So now that we've selected each one and we turn them from a string in, we're just using the path. So we turn them from an editor build scene, build setting scene, into a string, and that we pass into a new GUI content. So what comes out of this whole operation is an IEnumerable of new GUI content, or I believe, and that we need an array to actually use in the selector. So we pull an array out. I did all of this outside of the call, and so it will only be called once you click on the object and it's loaded the first time. But if the build scene settings changed, you won't get an update. So I put it in, and it doesn't use up so much cycle, like you don't see it lagging or anything like that. So it's fine here, in my opinion. If that needs to change, then this is where you change it. You can pull all of these out, because none of these need any of these properties that are coming in, but it needs to be updated every time. That's why it's here. Anyway, we do this also for the indices in the BuildScene array. So we select all of them. Notice here we have a different select, right? We select the first time we selected each element. Now the loop that's going to run is going to contain the element plus an index to that element in the array. So we can use that to say we know this path that was at I, that was at 0, we know the index to it. That's what this selector would do. So then we get that into an array. We get the attribute. That's the attribute we created. It's a property that's in the base class. So we get that and we cast into our own so we can pull the parameters out, which is the show button, and let me find the other one, thank you, and the use scene name. Okay, so now we have our property. We declare some padding or adjustments. We have our rectangle for those adjustments. Yeah, that should be much better. All right, and now we get the selected value. Getting the selected value also uses the system link namespace, I believe. This is how I chose to do it. You can also run a loop and pick them out, but that's what the namespace provides. You know, a short and quick way to get in and get one operation out. So we get the build scenes that we set here, and we find the index of that particular one. This is the first time we're going to use the incoming property, and that's a string value. So now from before, we set a string. That's why I don't like making changes. It takes time to spin up. But in our checkpoints, we select our scene names here, so we're entering a string value. This needs to be converted into a string value. These are integers that's being selected in the box. Hence we have indices and names. So we get the selected index, the name that matches the name that would normally be typed in. So we extract that all from the scene by calling this static function here. We'll get into that and see how that works. Equals on a string value always compares the content, and you can use the equal to operator. They work differently for different types of classes and objects and stuff, so I don't think you can just use them at any time to compare anything. I think it's okay in this case. So now we declare a way to draw our tooltip because we want to update it. So if we use in our attribute that were passed in, right? This is a lambda, an anonymous function. So anything that calls this, just pass in some text, a string parameter, and we'll convert it into a GUI content. Right. Speaking of which, we can. Oh, this GUI content has a tooltip. So it could probably just be used here also. Yeah, you know it actually can. Let me do that now while I'm thinking about it. So it's asking for a label. So if in here, oh, I put it too low. Well, I guess this was not supposed to be a coding tutorial, any of them. But where it fits, why not? Alright, so we declare the value, and it would give us that. No, that's too easy, because I'm doing it twice here. So if I pass that in, then I get everything. I get the tooltip and all of that. Okay, so let's move on. So now we get our selected value. If it equals -1, nothing selected. It just loads in whatever comes from the label. It uses that as its text to display. Else, if there is something selected, we check our attribute and see if we wanted to use the scene name. That means it's going to replace the name of the field with the name of this currently selected scene, which also means in an array, every element shown on that reorderable list would say element 0, element 1, element 2, or this label would say level names, and there would never be anything else. So you can use level name 0, level name 1. So now we give it the ability to show you the actual scene that's selected, because as you see, it's a little congested in here and you may not be able to see it all the time, but the tooltip shows which one's selected. Okay, so we get the selected value from all of that. We pass it into our int pop-up. We give it, show you these parameters. I think we're using that one. We give it the content, the label, the selected value, integer, the build scenes as the GUI content display options, where we converted them. I haven't saved this yet. It should work. And the indices, which is 0 to build scenes dot length. And now this turns all this nice stuff into a drop down selector that we can pick. And if something is selected, then we go about the business of converting it, because it's gives us drop downs because of the slashes. When we pull the scenes out, they have the complete path, assets slash scene slash, and it continues on. That's why it gives us a nice neat little drop down with arrows, so we can pick the any folder. It shows up separately, so we're not in control of how the output comes out of here. So then we see if we want to add a button after. That's the other attribute that's passed in. And what this does is add a little plus button right after this here, if that's set to true. In this case, there's a button here that opens it all up, so that's what that little button would do each time. So if we do say show the button, we get a rect for it, we align it, and then we call this function to draw it. This function we've seen before, that was pretty important, that extracts the name from the path. The path I told you is what's stored here, the complete path to that asset. And now we draw our little plus button if we so desire. We give it a rect to draw it in, a label, a text, and the style. And if that button is clicked, then we open the build scenes window. Alright, let's save this and make sure nothing's broken. Then we'll come back and explore the, where am I, the scene picker? We'll explore the build scene. I just want to make sure that change that I made at the top there actually worked, or doesn't change anything. I didn't think it would, because it's direct and I just ended up using it twice. That shows 1. And that shows 2. Alright. Still good. Cool. So now we're going into what actually draws this entire list. We just saw what draws one individual line, one individual row in this. So if you just had a string and you put it's a scene picker, it would give you this. We'll see that also later. Probably not in this lesson, but in others. So we've gone over the scene picker attribute. So you add it to any string. In this case, it just used the array of strings and it did it for each one. So this we used, oh my, the BuildScene. So this is what builds all of those. So we're getting into the persistent editor in a moment. All of these classes are directly or indirectly referred to in that editor. So our BuildScenes list uses reloadable lists from this namespace. We give it a header. Nothing much. We declare our button, what's going to be written on the button, header button, and we actually draw it, right? So what these are, we have our reorderable list. We are a reorderable list, and we have these functions or properties. I'm sorry, these properties, they're not properties, they're fields. These fields that we could assign delegates to that would be called on how to draw the header. So we would add our button to our label field that can, which we saw before, open the BuildScene settings, and we give it the appropriate parameters. For each element that's going to be drawn, we're going to do this. We're going to just call the editor, property field, and we draw it as a normal property drawer. This is a Unity thing. When it grabs an element, it knows it's an array. So it grabs that index and it just draws the normal property. We've defined what the normal property will be drawn like, or would be presented, how it would be presented in the inspector. This one just says, yeah, draw the property. If we didn't define this, it would be just drawing a string property. So it's text field, I believe it would use. So it would use a text field and draw something for you to type a text in. So Unity doesn't care how it is drawing the property, it just draws it. They have some ways to define it. Now you can define a way to draw the properties. So if we click the add button, we're going to do this stuff. We're going to insert an element at the last spot in the array. We're going to get the string value out of that, and we're going to clear it. Now that would set here to being -1 when it's selected, which will give us a nice blank drop down to select from. So now on to the last script, the one that actually draws our persisting game controller in the editor. It's not too much. Everything is defined outside, so we just call and manage what's been defined before. So we have our custom editor, and any classes deriving from here would get all this stuff. We have some constants to define the property name. So level index coincides with nothing in here but something in here. So that's where we pull our level index. Okay, on all the other property notations on here would do the same. So we get game info and we get the max pickups and so on. We have our excluded properties. In lesson 2A showed how this was done. So I'll refer to that, I guess. And here we use our BuildScene names. We declare it, declare some serialized properties. On enable, this is a Unity message or function, I believe. I keep saying message because I heard them say it's a message. It's not like actually a function that's written in, and I don't know how they do their stuff in the back. But anyway, we use it. And we declare our new build scenes. We give it an object, serialized object to work with, and the property name, which in this case is the level names that we're going to be working with. The level index, the pickups, and the game info. We want to show those. We disable them after drawing everything that preceded before we've added these new properties. And then we draw our list. Alright, so I didn't declare that function. It comes with the reorderable list. So we update and we apply. We don't update, we don't apply. Changes don't even show in the inspector. Alright, so that's, I think, the end of it. So this is our drawer of our persistent game controller. So again, our persistent game controller, once we pick up all the pickups that were dynamically counted at runtime, we reload another level defined by this list. Okay, so next would be our animator. Animation box and input controller. That was actually a pretty interesting level to, or a lesson to complete. So we're gonna create a box ninja that is animated. So all the animations would be here. There's no files. Ninja would be a box with box ninja parts and would be animated. Okay, so we've loaded the new map, and if we take a look over here, you see it's on level index 1 now. There's still 4 pickups that detected. We have 4 points, so we've picked up 4, and that information is still here. So that's how the don't destroy unload would work. And of course we can do a build to Android and tilt our Android device and move this guy around, tap our screen, and it will jump. Oh, the persistent game controller is a little nicer, right? See, it keeps flipping now. Remember, the checkpoints, the previous game controller didn't allow for that behavior. It stayed on the last one. So we're improving behavior on both sides, both ends, and we can sure fall from a long way. Alright, so I guess let me get this last one, and then I will end it. So thanks again. Next lesson 6, animating our ninja.